The Panther arrived in the yard at 2 miles an hour, being dragged by 2 British recovery tanks that looked resentful about the whole thing. It was early 1945 in Northern Europe, one of those bone-deep damp days where the sky never quite makes up its mind to rain. The war was moving east now, but the rear areas were still full of the debris it left behind. Burned-out half-tracks, piles of tracklings, stacks of unexploded ammunition marked with chalk warnings, and, every so often, an intact trophy too valuable to scrap. This one had started its journey as part of somebody's pride and joy on the German side. Panzerkampfwagen 5th SDK F-Surungay to the British. Its engine was dead. The final drive on the left side had gone first. There were tooth fragments and oil streaked down the inside of the hull to prove it. And somewhere along the toe back, a transmission bearing had locked solid like it was trying to weld itself to the shaft. The big cat's tracks lurched reluctantly as the ARVs tugged it into position, steel links clattering over the concrete cradle in front of the workshop doors. A small crowd had gathered to watch. Some wore tanker black berets, others Royal Electrical and Mechanical Engineers badges, others civilian overalls with Bovington or Chertsey stenciled faintly on the breast pocket. A few had seen Panthers through gun sights in Normandy, and seeing one this close without incoming shot was like meeting a famous boxer asleep in a chair. Others were more interested in what was inside the boxer. One of the Remy officers, a major with permanent oil under his fingernails and a notebook always sticking out of his battle dress pocket. "Right then," he said. "Let's find out why Jerry's pride and joy keeps visiting our workshops instead of ours visiting his." Somebody in the back muttered, "'Cause it's a shop queen, sir," and there were a few quiet laughs. The term had been making the rounds for months. A tank that looked murderous in silhouette and on pamphlets, but seemed to spend more hours up on jacks than down in the line. The Panther was the worst offender. It had a reputation among mechanics the way some actresses have a reputation among costume departments. Stunning on screen, murder behind the curtain. The Panther's silhouette was still impressive with the engine dead and mud clinging to its track guards. Low, long hull. 80mm of well-sloped frontal armour on the glacis, a plate that had mocked the 6-pounders and 75s in Normandy. The big, flat-sided turret with its massive mantlet. That wonderful 7.5cm Kodwer 42 L70 barrel jutting out like a spear. The British tank gunners in the crowd looked at that, but the men in overalls weren't here for the gun. They'd been reading combat reports for months. They knew what that L70 could do. Punch through a Churchill's nose at ranges that made British range tables look optimistic. Hammer a Sherman from 1,000 yards away before the crew even realized they'd been spotted. They'd seen the neat round holes in knocked-out hulls and turrets. Gunnery testing at Lulworth and Shoeburyness had already confirmed those numbers in cold, clinical terms. What they wanted to know now was why such a formidable gunnery platform kept arriving behind recovery vehicles with its tongue hanging out. The Panther was chocked, the ARVs unhooked, workshop doors groaned open, a gantry crane loomed above, massive hooks swaying gently. The Major flipped open his notebook and called out the first orders. Photographs all round, measurements, then we start with the turret and work our way down to the bits Jerry hoped we'd never see. The flash of cameras popped as the Panther was photographed from every angle. Chalk marks went on the side, labelling this hull as Pre-CV No. 3, Western Front Capture. Then the fitter teams moved in with spanners, drifts, sling chains and a kind of ruthless curiosity. Turret ring bolts were undone. The big cast turret, nearly 12 tons of steel and optics and fittings, rose on the crane chain, dangling in the air for a moment like a decapitated head. They popped off the rear access plates first. Behind the Panther's rear armour, under a deck covered in grills and flush panels, sat the Maybach HL230P30, a 23-litre V12 petrol engine, theoretically good for 700 metric horsepower at 3,000 RPM. In practice, running on increasingly poor fuel and built with increasingly dubious quality control, it delivered less, but still enough to make a 45-ton tank move like something you didn't want to stand in front of. The engine looked tired, sump dented, Oil everywhere. A few cooling baffles bent like they'd been kicked by a frustrated boot, but it was fundamentally sound. Pistons, bores, crank journals, once cleaned and measured, looked as though they would do their jobs if maintained properly. The British had seen Maybachs before and captured Tigers and earlier German tanks. They respected them, overcomplicated for field maintenance perhaps, but solidly engineered. It was when the chain of power left the flywheel that things got interesting. Between that engine and the drive sprockets at the front was the Panther's second heart, the 7-speed AK-7200 gearbox, and its associated steering gear, clutches, and final drives. It was compact for what it did. German designers had crammed the gearbox, steering unit, and final reduction gears into the nose of the hull ahead of the fighting compartment, a configuration that made the Panthers easy to drive into cover and offered good frontal armor concentration, at the cost of everything being crammed together like a crowded bar on a Friday night. The crane lifted the engine clear, dripping oil, and the fitters shifted their attention forward. Unbolting the gearbox was a job. German designers liked to integrate things. Getting the AK-7200 out meant disconnecting linkages, drive shaft, cooling lines, electricals, then attacking retaining bolts that had been tightened by someone with very strong wrists, and perhaps a bad temper. But British fitters were used to coaxing reluctant gearboxes out of Churchills and Cromwells. They swore in at least 3 languages and kept at it. Eventually, with wedges and swear words and a carefully rigged sling, the Panther's gearbox came free and was lowered onto a bench with a satisfying clunk. The Major and his team gathered around it like surgeons around a specimen. The casing was compact, with flanges for the drum-type brakes and steering clutches. Gears lurked inside, responsible for turning all that Maybach grunt into forward movement and controlled turns. "Looks clever," one of the fitter sergeants remarked, wiping his hands on a rag. "We'll see if clever means good." They set to work on the end caps. Under one, the steering control gear, under another, the main gear train. As the covers came away, clusters of gears appeared, their teeth slick with dark used oil. On the surface, the gearbox impressed. Multi-plate clutches, epicyclic gear trains, 7 forward ratios, reverse arrangements that looked efficient on paper. It promised smooth shifting if everything was in adjustment, and steering that offered fine control with small inputs. But the more they looked, the more questions they had. Gear teeth where you expected broad faces and generous root fillets were surprisingly narrow. The material, when tested later, would show decent case hardening, but not enough depth, not the kind of over-engineering that British designers favoured when they suspected. One of the engineers traced the torque path with a pencil and scribbled numbers in his notebook, muttering under his breath. 460-odd kilowatts in at full chack. Gear ratio here gives so much torque at the output shaft. Then you hit the final drive. He tapped the diagram. All of that ends up going through this little set of teeth. He and the Major looked at each other. Those teeth, those final reduction gears snug up against the inside of each front sprocket, were the Panther's Achilles heel. Reports from the field, German field reports, captured with other documents and translated in the back rooms of intelligence sections, had already hinted at it. Panthers laid up with shattered final drives after relatively short marches. Gear teeth sheared clean off after one too many shock loads. Average distances between failures measured not in the thousands of miles Allied crews expected from their transmissions, but in tens, dozens of miles off-road. That, in the mud and violence of the Eastern Front and Normandy, was a terrifyingly small number. The British now had the parts in front of them to see exactly why. Each final drive was a 2-stage spur gear reduction box, taking the output from the main transmission and dropping it down to the speed and torque required at the track. In theory, nothing exotic. In practice, the whole unit was underdimensioned for the job. Gear width was limited by the space available inside the hull nose and behind the sprocket. The teeth themselves were cut with involute profiles that looked fine on a drawing, but when combined with the Panther's weight and the torque being shoved through them, they lived hard lives. The Panther in the workshop had already sacrificed one of its final drives. When the British cracked the casing, they found teeth missing in jagged clusters like a row of houses after a bomb. The engineer ran a finger over a broken tooth, feeling the rough grain of the fracture. "You hit a rock at speed," he said quietly, "or you chop the clutch in too hard, and all that shock has to go somewhere. It goes here, and this little beggar gives up." He turned to the major, who was already ahead of him. "Multiply by, what, 45 tons, and a driver who's been told to get to the front yesterday," the major said, "and you don't have much margin. No wonder Jerry diaries are full of Panther in Werkstatt again." The numbers backed the impression. German data, when you could trust it and when you corrected for their tendency to measure in kilometers and hours rather than British miles and days, showed mean distances between final drive failures for early Panthers in the range of 50-60 miles of hard cross-country use, sometimes less, off-road marches of 30 miles to reach a forming up point, before an offensive could leave a third of a Panther battalion trailing broken-down cats along the route like breadcrumbs. British experience at the front had mirrored that. In Normandy, Panthers often appeared at the edge of the battlefield, with a trail of immobile comrades behind them, each waiting for recovery vehicles and mechanics, who might never arrive under Allied artillery fire and fighter-bomber attack. Tankers had noticed, and so had the recovery boys. Now, with sprockets and final drive gears on benches, the inquest became real. They compared it, naturally, to their own kit. Cromwell's, Sherman's under British use, Churchill's. British and American tanks had their own transmission woes. No one who had fought with early Churchills would ever quite forget what a broken gearbox smelled like. But by the time Normandy rolled around, Allied automotive reliability had reached a point where you could reasonably expect a tank to cover hundreds of miles on its own tracks between major failures. A Sherman might lose a bogie in rough ground. By contrast, the Panther's automotive system felt like something that had been rushed into service in a hurry, which of course it had. The Germans had needed something to counter the T-34 after their ugly shock in 19. They designed the Panther in a fever, taking cues from the T-34's sloped armor and wide tracks, topping it with a high-velocity gun, and accepted compromises in the drivetrain to get it into production quickly. On paper, the numbers balanced. In Russian mud, they did not. British engineers stripped down the rest of the Panther's running gear as they worked through the hull. The torsion bar suspension was elegant. Long internal bars running across the hull, each supporting a swing arm and a pair of interleaved road wheels. It allowed the Panther to ride smoothly at speed, to keep that long 75mm gun steady as it pounded across fields. Firing trials had shown that the Panther was a stable gunnery platform. The suspension was a big part of that. But it was maintenance heavy. Removing a damaged inner road wheel meant removing outer wheels first. Mud and ice clogged the interleave pattern in winter, freezing solid and straining bearings. The wide tracks offered good ground pressure, better than a Sherman, but each track link was a casting more complicated and resource-intensive to make than Allied stamped designs. When the Panther worked, it worked beautifully. When it didn't, it asked a lot of the men with spanners. It was a pattern the teardown kept revealing. They looked at the cooling system, the radiators arranged in sponsons, the fans driven by belts and shafts, a layout that gave good airflow when everything was intact, but became a nightmare to fix, when a single component broke in combat, and your only parts department was a field workshop, with a table of scavenged bits. They noted how much of the front-end automotive kit had to be stripped out through the fighting compartment, meaning serious drivetrain repairs took the tank out of action for days at a time. They inspected the hull welds. The armor plates themselves were generally sound, though some late-war German armor showed signs of declining steel quality. The slope of the glacis was still a work of art. British range tests had already taught. In the yard, after long days inside the belly of the beast, the jokes started to take shape. "Beautiful gun that," one fitter would say, nodding toward the Panther's turret sitting on its stand. "Shame they put it on top of a Hewitt crane. 45 tons of hull, 30 of which is drivetrain, 20 of which stays in the workshop," another would answer. "Shop queen," someone else would mutter, and the phrase would stick. The numbers they pulled out of their tests made the joke sharper. They reassembled the least damaged of the captured Panthers as best they could, fitting new bearings, welding and grinding the worst damaged teeth, honing, shimming, doing everything a meticulous Remy unit could do to give the machine a fair trial. Then they took it to the test track and ran it hard over cross-country courses that mimicked the worst a tank would face. Churned fields, sudden ditches, abrupt gear changes, quick steering inputs. They treated it as if it were going into battle tomorrow and being driven by men who had slept 3 hours in the last 2 days and were hurrying to plug a gap in the line. They logged miles, hours, and every temperature and noise the Panther made, and then, after perhaps 40 or 50 miles of spirited cross-country useless, in one case, they heard the tooth-grinding bang from the nose that German crews had learned to dread. One final drive went. In another test, a steering gear started shedding metal into its oil, a bearing having decided enough was enough. These weren't catastrophic hull ruptures, they were the small cumulative fractures of a design being asked to do a job it could almost, but not quite handle over long durations. Mean time between failures, that's what engineers call the number. In reports, it appears as a neat acronym, MTBF. For early Panthers, the kind being tested in those British workshops, the MTBF on the automotive side wasn't measured in the thousands of miles Allied planners liked. It was off-road, in the dozens. In a war of maneuver, that is a strategic number, not just an engineering footnote. The British engineers wrote it down. They collated it with intelligence summaries from out in the field. Logistics officers did their own mental arithmetic. Say you have a battalion of Panthers, about 45 runners on your books. You need to move them 50 miles to meet an Allied breakthrough. The roads are cratered, the verge is muddy, the drivers are competent, some seasoned Eastern Front veterans, some teenagers with only a few weeks at the controls. Based on what the British now know, maybe a third of those tanks will suffer serious drivetrain trouble in that move. Final drives gone, transmissions cooked, clutches failing. For each immobile Panther, you need a salvage vehicle. Germany had designed the Berger Panther for exactly this role, but there were never enough of them. You need spare final drive units, a heavy, awkward component that requires cranes and special tools to swap. You need transports for those spares. You need hours, and men, and fuel. All of these things, by 1944, are in shorter supply for the Wehrmacht than courage. And even if you manage to coax 30 out of 45 Panthers to the battle area, you now have a chunk of your precious armoured strength scattered along the routes, waiting to be dragged back into workshops that are themselves under threat from artillery and fighter-bomber attacks. Meanwhile, the British or Americans, with their less glamorous but more forgiving Shermans and Cromwells, can bring a higher proportion of their tank inventory to the fight intact. A Sherman may burn if you hit it. A Panther may never arrive in a place where anyone can pull a trigger. That's the underlying joke behind the shop queen quip. For every hour you see a Panther looking deadly down a hedgerow, there are many hours where it's nose up on a jackstand while Oremy's German counterpart scrabbles for gears that won't shear. Back in the workshop, comparing notes at day's end, the British engineers understood that this wasn't just about schadenfreude. It was about philosophy. They'd learned hard lessons themselves early in the war. British cruiser tanks in the desert had run their tracks off, broken suspensions, cooked radiators, snapped final drives. Churchills in Tunisia had broken down in humiliating numbers until their teething problems were sorted. Those experiences had forced a re-evaluation of automotive robustness as a key element of battleworthiness, not an afterthought. By 1944, British and American tank designers were designing with maintenance and longevity in mind. Gearboxes were overbuilt where possible. Final drives were given safety margins. Components were standard. Looking at the Panther's gearbox and final drives, the British didn't see a failure of German technical skill. They saw a different set of trade-offs. German engineers, under political and battlefield pressure, had prioritized getting a high-performance gun platform to the front quickly. They'd been willing to accept that automotive components would live hard, dangerous lives so long as the Panther could stand in front of T-34s and Shermans and win gunnery duels. They'd counted on high-quality steel and careful driving to make the numbers work. They'd also counted, consciously or not, on a battlefield rhythm where tanks fought relatively close to home bases and repair shops. The reality of the Eastern Front, and then the Allied advance in the West, hadn't respected those assumptions. When the British reports on the Panther finally circulated to design staffs and senior officers, their conclusions were brutally clear. Yes, the Panther's gun was excellent. The Cowan K-42 was a masterpiece of ballistics for its caliber, with high muzzle velocity, good armor-piercing performance, and a flat trajectory. Yes, the front armor scheme was formidable. Yes, the suspension made it stable and accurate on the move. As a gunnery platform, the Panther was something to respect and in some ways emulate. But as a fighting vehicle in a prolonged campaign, the Panther came with a heavy, hidden logistic tax. You didn't just buy the tank, you bought the shop it lived in. You bought the recovery vehicles to drag it back when, inevitably, something inside its nose let out a bang and a shower of gear teeth. You bought the spare parts, made from scarce alloy steel, machined to precise tolerances in factories being bombed nightly. You bought the fuel and oil to test it after every major repair, because you couldn't afford to have a freshly repaired Panther break down again 5 miles from the workshop. You bought the time of skilled mechanics and fitters, men with years of training who could have been doing other vital war work. An armoured regiment with Panthers needed an armoured regiment's worth of spares and recovery capacity behind it. Allied staff officers, who lived and breathed tables of equipment and maintenance schedules, understood what that meant in tonnage and manpower. British engineers, in their tear-down reports, didn't phrase it quite that way. They used more restrained language. They talked about complexity of transmission and steering gear. In the messes and workshops, the same conclusions came out as jokes. "Lovely front," a sergeant fitter would say about a Panther, "if it ever shows up to use it." "Shop queen," his mate would reply. "We ought to paint it on the side in German for them." The jokes had a bite, but also a certain respect. No one could deny what the Panther could do in the 5 minutes everything worked. Some of the engineers thought further ahead than the next breakdown. When they went back to their drawing boards, or when they scribbled notes on the backs of envelopes to send to colleagues in design establishments, they carried the Panther with them, not as something to copy wholesale, but as a cautionary tale, and a source of ideas. Sloped armor on the glasses, absolutely. The British Comet and the post-war Centurion would echo that. A high-velocity, high-penetration main gun, without question. The 17-pounder had already shown its worth in Fireflies. Future designs would integrate big guns more gracefully. Torsion bar suspension and wider tracks for lower ground pressure. Both worth serious consideration. But the final drives, no, those would become an example of what not to do. Battle-worthiness, the British concluded, was not just about how hard something hit or how thick its front plate was. It was about how often it could show up to the fight, how long it could stay there, how easily it could be dragged back and restored to fitness, and what kinds of things tended to fail under stress. A Panther's gun might win a duel. A Panther's gears might lose a campaign. One evening after another long day of examining fractured gear teeth under a magnifying glass, the Remy Major closed his notebook and leaned back on his stool. "Do you know the worst of it?" he said to the young lieutenant beside him. "What's that, sir?" "If Jerry had had the same industrial base we've got behind our Shermans, he might have been able to afford this nonsense. Spares by the wagon load. Recovery vehicles all the way to Berlin. As it is, he's got these beautiful fragile beasts, and not nearly enough trailers to carry them when they throw their toys out of the pram." The lieutenant nodded, picking up a broken tooth and feeling its weight in his palm. "We respect the gun," he said, "but I don't envy their mechanics." "Quite," the major said. "Now let's see how many miles we can get out of this next one, before it goes bang. I'd like the numbers to be right when some bright spark in Whitehall asks whether we should build a British Panther." They did the test. Instead, Britain and her allies went down the road that would lead to Centurion and Patton. Tanks designed not just to be deadly, but to be durable. Tanks whose glory hours were measured not against how tight a turn they could fire on the move, but against how many miles of peacetime training and wartime campaigning they could cover without needing major surgery. The Panther, for all its formidable qualities, remained in their minds what they had seen on the workshop floor, a splendid predator spoiled at the ankle. In museums today, when you walk past a Panther, you still hear people talk about its gun, about its sloped front, about how terrifying it must have been to face one across a French field. The plaques will mention its impact at Kursk, its presence in Normandy, its legacy in post-war tank design debates. In the back rooms, in the maintenance bays, the old stories go slightly differently. Someone will mention the final drives. Someone will mention gear teeth like broken gravestones in an oily graveyard. Someone will repeat an old line, beautiful to look at, hell to keep running, shop queen. In the end, British engineers tore down a Panther's gearbox and final drives, and didn't love what they found. They respected the sophistication, admired the ambition, but doubted the wisdom. They saw how often the parts that made it move betrayed the promise of the parts that made it deadly. And from those broken gears,